start the pre-algebra class. We're starting in Unit 1, Variables, Expressions, and Integers, and we're also going to start with Section 1.1, which would be on expressions and variables. Now, in your previous math classes, you spent a great deal of time going over adding, subtracting, multiplying, and dividing whole numbers, integers, fractions, decimals. We're going to draw from that wealth of knowledge that you have, and we're going to expand upon it. We're going to start off with some review, and then we're going to go into some new topics. And the new topic in this section, of course, is the idea of a variable. As a math teacher, I've been asked, what's the difference between arithmetic and algebra? And I always tell them it's the idea of a variable. Now, we'll start off with something that you're familiar with, and that's a numerical expression. And here's the definition. So you should get your notes out and copy these definitions and examples down. Definition here, a variable expression consists of numbers and operations. Not much of a definition, more of a description. Numbers, of course, operations, adding, subtracting, multiplying, dividing. And you can see some examples. Here's one with addition, 5 plus 12. There's another one with addition and subtraction. Now the third example involves division, but we can also write division as a fraction. Something like that. That refers to division also. And then this fourth example, multiplication, there are a number of ways you can write a multiplication expression. You could use the dot in the middle. You could use parentheses, so something like this, 6 times 7. Notice there's no symbol between, but that implies multiplication. You can have two sets of parentheses. Parenthesis right next to another parenthesis with no symbol in between also implies multiplication. Now we get to the new stuff. The idea of a variable. A variable is a letter or a symbol that's used to represent one or more numbers. We typically use just traditional letters, lowercase, and the one example I have written down, as you can see, is an X. But you can use a Y or an A or a B, usually lowercase letters. Sometimes capital letters are used. I would stay away from like a lowercase letter S, which looks a little like a 5, or a lowercase letter O, which looks a lot like a 0, or even a lowercase letter B. Sometimes the letter B looks a little bit like a 6 when you write it out. But X's and Y's work fine. Now, if we combine these two ideas here together, we have a third definition, which is a variable expression. It consists of numbers, variables, and operations. And as you can see, I have three examples down here. The first one, x plus 2. X is your variable. It represents a number. It could represent the number 5. It could represent the number 10. But in this case, we don't know what it represents. We use it just as to show that unknown, x plus 2. The next example, 6y minus w, 6y minus w. The 6y, again, there's no symbol between the number 6 and the variable y. That implies also multiplication. That means the same as 6 times y. So that's the same as 6 times y minus the variable w. The third example, I actually put the multiplication sign in between the number and the variable, which you can do. That means 5 times a, but this can be written as 5a. Now, since variables represent numbers, when you have a variable expression, you may be asked to evaluate or define the value of, that's what evaluate means. Notice that the base word of evaluate is value. To find the value of the expression, when you substitute in for these variables, variable or variables, numbers that are given. So to evaluate an expression, really two steps. Substitute a number in for each variable and then simplify the resulting numerical expression. Or as I like to say, plug and chug. You plug the number in, you grind out the work. And I have some examples here that I'm going to show you. The first one says evaluate this expression x plus 2 when x is 15. So what you're going to do is you're going to substitute the 15 in for the x. And I have 15 plus 2, which of course is 17. Now the next expression is a little trickier because you have 6y. Remember, when the number is next to the variable, that implies multiplication. So 6y minus w means 6 times y, that's what's going to go in, 5 minus w, that's the 8, that's what's going to go in for there, 8. And we're going to multiply first, 30 minus 8, or 22. Here's one where there's two variables right next to one another, and that of course also implies multiplication. When there's no symbol between, and it refers to multiplication, a times b. So if I substitute the 4 in for the a and the 3 in for the b, I get 4 times 3, which of course is 12. And the last example, the reason I put this one in is because sometimes students get in a hurry and they see that the first variable given, in this case x is 6, they plug it in for the first variable in the expression, even though the first variable in the expression is y. So be careful, make sure you plug them in for the right variables. This is going to go in here, and this is going to go in here. So I'm going to get 12 plus 8. Now 8x means 8 times x, so this would be 8 times 6. We're going to multiply first. This is going to be 12 plus 8 times 6, of course, is 48. And then we'll add, and we get 60. And that's our. One of the uses of a variable is because we can use it to create models, verbal models, that would represent real-life types of applications. Now, what we're going to do is we're going to have to be able to translate words into algebraic symbols and vice versa. So we're going to start off by translating words into symbols, and to do that, we need to know some of the key expressions and what they represent. And so I have listed at the top here a few expressions that represent the 4 major operations and, of course, the idea of a variable. Notice that for addition, plus, sum, total, increased by, greater than, more than, added to. Those are just several of the types that you might come across. There are more, I'm sure. Notice that more than is underlined, and I'm going to get to that one because more than kind of is different than the others in that it kind of switches the order around. And we'll get to an example of showing that in just a minute. Subtraction, minus, difference, that's a good one. Decreased by, fewer than, less than, like more than, it's underlined. I'm going to get back to that. And subtracted from. Those are all expressions that represent subtraction. Multiplication, of course, the word times, the product of, multiplied by, and even the word of, used in the right way, can represent multiplication. Division, you have divided by, the quotient of, split evenly. When something is split evenly, you're dividing by how many you're splitting it into. And then one that's kind of looks like divided by, but it's divided into. And there again, we've got a little bit of interpretation on what's being divided by what when we use these expressions. And I'm going to get to an example of that one also. And then I just listed one example for a variable, and that's when they use the expression like a number. Because they don't tell us what the number is, we just have to assume that it could represent any number, and that's where the variable comes into play. So what I have here, it says write a variable expression, okay, remember variables, numbers, operations, to represent each of these phrases. Now, I'm going to identify the key word here. In this case, it's product. Product refers to multiplication. So I'm multiplying the 25 and a number. The product of 25 and a number. So 25, and for the number, I'm going to use n. The variable n. So I'm going to write 25 times n, or I'm just going to write 25n, because again, number right next to the variable implies multiplication. Now here's one of the ones that I had underlined from up above. More than. 6 more than a number. It refers to addition. No problem there. You're adding on. 6 more than a number means you're adding the 6 onto this number. Again, I'm going to use n for the number. But instead of writing it in the order that I read it by putting the 6 first, 6 more than typically refers to that you're adding the 6 to the number n, so you would put the 6 last. You would write it as n plus 6. Now, if you're wondering, well, I know that with addition, if you change the order around, you get the same answer. Well, that's true, but I'm just kind of going by the letter of how it's written out here. So I'm going to write it as n plus 6. Now, in C here, I have less than. And less than, like more than, kind of switches the order around. It says 8 less than a number. Less than is subtraction, but it's not 8 minus the number, it's 8 less than the number, means you're subtracting the 8 from the number. Again, I'm going to use n, so I'm going to write n minus 8. Now here order is extremely important because if you switch the order around, 8 minus n does not represent the same expression. All right, in this case, a number of inches in x feet. Now there's no operation sign given here, but we do know that when you convert feet into inches, there's 12 inches to a foot, so however many feet you have, you're going to multiply it by 12. So that part you'd have to interpret from reading the statement here. So this is going to be 12 times x. The quotient of 5 and a number. Now, quotient refers to division, and of course the order that we write a division is also very important. 10 divided by 2 and 2 divided by 10 are two separate things. So I've got to make sure I have them in the right order, and in this case, when it's using the quotient of, you put them in the order that you read them. So it's the quotient of 5 and a number. It means 5 divided by the number n, or you could have 5 over n, like this. And this last example, I used divided into. Divided into is the third one that I made mention of before, where the order is extremely important here, because 5 divided into a number means you're dividing by the 5. 5 is the divisor. So you're dividing the 5 into the number, so it would be n divided by 5, or again, you could have n over 5. So look through these notes, make sure that you have the examples written down, read through them a few times before you get started on your assignment, and remember, practice, practice, practice.